All right, as you can see, this is day 2 of the Algebra 1B repeat practice exam. And so for the next few problems, excuse me, the next 3 pages, I think this page is probably the easiest. Knowing when something is linear, exponential, or quadratic, right? Quadratic is the ones to x to the second power. And this right here is a picture of a quadratic, okay? And quadratics go kind of down and then up, or they go up and then down, right? So they have kind of changing values that increase and then decrease, or decrease and then increase. This is all consistently going down by 3. This, well, it's hard to see from here to here, but from 1 to 2 we either add 1 or times 2. From 2 to 4 we 2. Okay, so this is times 2, times 2, times 2, and half times 2 is 1. That makes sense. This one here is going down 6, then down 2, then up 2, then up 6. Oh, that's probably what this is then. So that's quadratic. Okay, exponential goes up real fast or down real fast if it's like this, right? This is going up real fast. That is exponential. And this graph is exponential. Okay. Then we've got linear is the only one left. Well, linear means line, right? So linear obviously is that one. And it's this one because it is consistently, think about this. This is going up and then up and then up and then up. Or in this case, it's going down and then down and then down by the same amount every time. That rise over run really, right? -3 over -1, -3 over, or +1, excuse me. -3 over +1, -3 over +1, right? So it's consistently going up by adding or subtracting. It's linear. If it's times or divide, it's exponential. If it's increasing, then decreasing, or vice versa, okay, then it is quadratic. Okay? This one here is not one of them. Okay, that's actually an x cubed. It's a negative x cubed function, nothing you need to know. So that's how those work. Linear, again, adding, subtracting, exponential, multiplying, divide. This is the graph of an exponential. This is the graph of a quadratic. Of course, that's linear. And quadratic, again, is increasing, decreasing. Okay, down to the bottom here. These 2 problems here that work the same using this formula right here. So you write that in first. -16t squared plus the 256 given there equals the ground. And the ground is height 0. Whereas the second problem, same equation. 16t squared, it's giving us that value instead. So plus 438 equals, it's not the ground, it's a 6-foot person. And for both of these, we do the same steps, which if I were to give you 3x minus 4 equals 9, what would you do? You would add 4 to both sides first, right? And you would get 3x equals 13. That's not going to work as nice as I wanted, but same thing here. Minus the 256 to both sides first. Those cancel. -16t squared equals -256. I'm going to actually minus 38 here too. 438, so you can see it's the same steps. Again, those cancel. I get to the same step here. And if I go here, I say, what would you do next? You would say, I would divide. Well, it's the same thing here. Even though it's a t squared, we still want to divide next. Kind of order of operations backwards. So those will cancel. I get t squared equals 16. Those will cancel. I get t squared equals 27. And to the opposite of squaring something is to square root it. And so technically you get plus or minus, but you're not going to have negative seconds. So this is just 4 seconds. Okay. When I do the same here, I get a decimal. It is 5.2 seconds. Okay. And that's it. That's how you do those 2 problems. Let's go on to the next page. And we are going to have these graphing problems. I'm going to start actually at the bottom of the page because these are really, really easy. We had these on one of our mini quizzes. It's literally just identifying the vertex. And this vertex is over 1 and down 2. 1, -2. This vertex right here is -3, 2 because it is 3 left and then 2 up. Now what that gives us when it's in this formula is vertex form. This HK is the vertex. So H is just 1 and K is just -2. Okay. Same thing here. H is -3 because it's the x value of the vertex. The y value of the vertex is K. And that's it. It's that easy for those problems, okay? Now, I'm going to use that actually to do part A up here, okay? So the vertex is in that spot, like I said. So in that spot, and it is, we've been saying this, opposite, same. So -2, -3 is my vertex. So my axis of symmetry, I'm going to plot that point, -2, -3, is down here. Right? And the axis of symmetry goes right through that line that we can reflect it across. So that's just x equals -2. It is always the x value of the vertex. That'll happen over here as well. Okay? The y-intercept is 0, and then plug 0 in. So when I plug 0 in here, I get, well, 1/2 times 0 plus 2 squared minus 3 equals. I plug that into my calculator, and you know I'm going to plug this in just like I did yesterday. So hopefully we can see this as good as we did yesterday. Yep. All right. So 1/2, I can just literally go 1 divided by 2 in parentheses, and then plug that in. 0 plus 2, and then squared. Minus 3. Right? I'm plugging in exactly how I see it. I get -1. All right, cool. So that's my y-intercept. So I'm going to go graph that. -1 right here. Right? I can see that that is 2 boxes away from this reflection line, so I go 2 boxes the other way. There it is right there, and that point is -4, -1. So I graph it, I reflect it, and then I see that that point is that. There's my graph. Done. I'll come fill in these down here in just a second. Let's go do this other line too. The vertex, I'm telling you this right here, right? Use it. This is your A, your B, and your C. So the x here, which is our axis of symmetry, it is also our x value of our vertex, is the opposite of B, so the opposite of positive 8 is -8, over 2 times -2. And you have to do this with kind of parentheses around that bottom. Because if you otherwise you get -8 divided by 2 is -4 times -2 is 8. When that is not what it's wanting you to do. It wants you to multiply the bottom first and get 2. So 2 is that, and 2 is that. I go and I plug 2 back in. Here, if I plug -2 in, I get 0 squared is 0 times that is 0 minus 3. That's how I get -3. So let's go plug that 2 in. I get -2 times 2 squared plus 8 times 2 minus 5. Again, I'm going to plug that in just like I see it. -2 parentheses 2 squared plus 8 times 2 minus 5. And I get 3. Okay, so 2, 3 is my point. Let's go graph that. 2, 3. Right, you can see your line of reflection here, your axis of symmetry is on the x equals 2. That's why I had that. The y-intercept is 0, plug 0 in, and 0 plus 0 minus 5 is -5. It's always 0, see? So plot that, 0, -5 way down here. 2 boxes away, go 2 boxes away. That would be 4, -5 to give me that reflected point, and then connect my dots. And then a lot of this is kind of symmetric, which is why I wanted to do it. The domain for these, they always keep going left, keep going right. It's all real numbers. Okay, we can put that in there first. The range, okay, is y values, and if it goes up, it's greater than or equal to. If it goes down, it's less than or equal to, and it is always the y value of the vertex, which in this case is -3, and in this case is +3. The increasing and decreasing is that thing with the left hand trick and the arrows. So we take our left hand and cover this up. That side's going up, so it's increasing, that side's decreasing. Over here, when I cover the left side, that side is going down, and so this side is increasing. And then what I said is if you just draw like a number line by it, you can just kind of decreasing gets that arrow, increasing gets that arrow, increasing gets that arrow, decreasing gets that arrow. And these x values are always the x value that you were using up top as well. So in this one it's -2, right? Because it decreases till you get to -2, then it increases. This one, it's 2. Because again, it increases till you get to where x equals 2, and then it decreases after that. Okay. All right, that's that page. Let's go on to one more. Okay. You're welcome for putting this on there. It probably doesn't need to be on the exam, but I want you to have it anyway, and rather than give it to you as a cheat sheet, just fill it in, and you can use a calculator. Like literally, you can just go, whoops, 1 squared, 2 squared, 3 squared, and start writing those numbers in, right? That's not hard. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. If you don't know the trick, there is a trick. It's plus 3, plus 5, plus 7, plus 9, plus 11, 13, 15, 17, 19, 21, 23. It's going up by an odd amount, going up by 2 more. It's that simple. So square root of 36 is right here with a negative sign there, makes that negative 6. 45, this is one of the tougher ones, I know this. We got to break that 45 up into something that can multiply into it. And 1 doesn't go into it, and 4 doesn't go into it, but 9 does. Square root of 9, and it goes into it 5 times. Well, the square root of 9 we can do, and the square root of 5 we can't, so we leave it like that. Okay? For this one, square root of 64 and square root of x to the 6, well, that's easy. Square root of 64 is just 8. It's right from my table. And this, all we do is just take 6 and divide it by 2, because square root means the opposite of is basically dividing exponents by 2 to just give me x3, which kind of helps us do this next one as well. Square root of 9, 3. Square root of x squared means 2 divided by 2, which is just x to the first. And square root of 25, it's just 5, just square rooting each term. Okay? This is just adding like terms. If I said 2x plus 3x, you would tell me that was 5x, because there's 2 of these and 3 of these gives me 5 of these. So if I have 3 of these minus 7 of these, I get minus 4 of these. Don't change what's underneath the sign. They are like terms. Just like these are like terms. And 5 plus 7 of these is 12 of these. It's that simple. For this problem, you're going to times what's outside by what's outside, and 3 times negative 2 is negative 6. And what's inside with what's inside. And square root of 7 times 7 is 49. This is a times problem. See, there's no like subtraction signs. That's a negative sign, by the way. And so this means negative 6 times, well, the square root of 49, which is 7, and that is just negative 42. And then for the next problem, this is a distribute because there is a minus sign here. So this is getting multiplied there and there. When I do it here, what's inside with what's inside gives me 3 square roots of 9 minus what's outside, which is 1 times 1, and then square roots of 3, because there's nothing on the inside of the square root to multiply. This can be simplified because the square root of 9 is 3, right? And 3 times 3 is 9. I don't need that one necessarily. If you have it there, it's not wrong, but that's it. That's the answer. Okay. The next few problems are just determining linear, exponential, quadratic, and radical. I probably should have put all these problems together on the exam. But linear, again, is just y equals mx plus b, which is right here. That's the easiest one. Anything to the x power is exponential. Okay? This is a radical sign, which makes this quadratic, which again is an x squared. X squareds are always this kind of thing, so that's quadratic. Okay? So that sign means radical. No exponents at all is linear. To the x power is exponential. To the second power quadratic. Okay? All right, so again, we did problems like this earlier. Actually, just talked about what is the opposite of squared. It's square root. So the opposite of square rooting something, excuse me, is to square both sides. So in other words, the square root of x squared would cancel each other out and just give you x. So I'm going to square this side and square this side, because again, whatever you do to one side, you have to do the other. These things cancel, the square root and the squared, so I'm just left with 2x plus 1. And over here, 5 squared is not 5 times 2, it's 5 times 5, which, again, we can get up here from this table is 25. So 25. And then you just go through the math. Of course, solving for x here, of course, you would subtract 1 first. This should be elementary by now. And then divide to get x equals 12. Okay. I could check this, plug it in for x, so I get 2 times 12 plus 1. Does that equal 5? That's 24 plus 1, which is the square root of 25. Does that equal 5? And it checks. Okay. Next problem, I would have square root of 2x minus 3. I want to add 2 to both sides first, because the only time I can square root this is if it's just by itself. So I do that and I get negative 3. I'm going to square both sides. Those will cancel. I get 2x minus 3. This is negative 3 squared, which is 9. Of course, I would add 3 here. 2x equals 12. divide by 2 to get x equals 6. And then go to check it. So 2 times 6 minus 3 minus 2 equals negative 5. 12 minus 3 is 9. Square root of that is 3. Actually, I can just write that, square root of 9 minus 2 equals negative 5. And 3 minus 2 equals negative 5 is not true. So that would be not true. It would be no solution. Okay? I didn't even need you to go that far. If you had square root equals a negative number right here, you could have stopped and said no solution right away, but without showing the rest of your work, because you can never have a square root be a negative, ever. Okay? All right, so down at the bottom. First thing I'm going to do for A, again, I'm trying to solve it for x squared, so I want to get rid of what is not x squared, which in this case is this 9. So I'm going to minus 9 to both sides. Those will cancel. X squared equals negative 3. And just like I said up here, when you get a square root equals negative, you can't have that. I would go to square root both sides. And even if you go plug it in your calculator, look what happens. I'm going to go second squared for x, square root of x, excuse me, and type in negative 3, and see what it says. Error, non-real answer, because you can't take the square root of a negative. Okay? So I'm going to quit that so that when I come back to it, I'll be able to do something else. Next problem, B. Again, minus 9. It's just like that problem where I said if I got 3x minus 4 equals 5, what would I do from there? Add the 5, then divide. So here I need to minus the 9. And 9 minus 9 is 0. And then divide by the 4. And then square root it to get x equals 0. Nothing else you can do there. Okay. On the next problem, we've got, again, same format. Get rid of the 25 first. Okay. Divide by 3. And where this comes in a little different is there's two answers. The square root of 25 is 5. But because it's x squared and I'm solving for x, it's got to be plus or minus, because if I plug 5 back in here, 5 squared is 25, times 3 is 75, minus 25 is 50, it works. But if I plug negative 5 in here, negative 5 times negative 5 is a positive 25, times 3 is 75, minus 25, it still works. Plus or minus is the answer there. And that kind of comes into play with this one. When I square root both sides right away, because there's nothing to add or subtract here, those will cancel. I get x minus 1. But again, when I square root that, I get plus or minus 6 when I'm solving for x. Now this becomes x minus 1 equals, well, positive 6 from that, and x minus 1 equals negative 6. And I will do the same thing to everything to solve here. X equals 7, x equals negative 5. Okay? I can plug them back in. 7 minus 1 is 6, 6 squared, 36, good. Negative 5 minus 1 is negative 6. Negative 6 times negative 6, yep, 36, it works. They're both right. Okay? And that, ladies and gentlemen, is the rest of practice exam part 2 in just over 18 minutes. Make sure you get this stuff in. Guys, I'm going to collect this on exam day, so keep it until then. But please have this entirely filled out and look this stuff over. The exam's going to look just like this, guys. Just like it, just different numbers. Study up. Good luck on your exams.